Okay, so find the intervals of increase or decrease. This is out of your book. These are the directions out of your book. Find the local max and mins. Find the intervals of concavity and with that the inflection points, and then sketch the graph. Okay.
Did you throw me a tablet?
I can. Should I throw it like a frisbee this time?
Yeah,
or
tell
tomahawk it?
Veronica to duck.
Okay. I don't know what. I think the thinner tablet would throw better. All right.
Woo!
Oh, that was so nice. Thinner
Every time
tablet's
you
the
say
way to go.
tablet, I'm like, what electronic device?
That's what I want to say.
Same, I
It's
always
funny.
think
It's
it's
the old
that.
school tablet.
Old
Yeah.
school.
Old school
Right.
tablet.
Okay.
This thing-
OS. It's a tablet OS.
I went up. Stone.
I will not tell Veronica to duck, then I'll tell her to move when I throw that to you. All right, so here's the function we're going to do. 200 plus 8x cubed plus x to the fourth. Which, by the way, what is its y-intercept? 200, right. X and y intercepts are optional, okay? If they're easy to get, you might as well get them. That one was kind of an easy one. All right, so we're going to start out with what, first derivative? And second derivative? One thing I guess I should have asked you, should we be worrying about asymptotes here? Because you would want to label where your asymptotes are. Write down where they are. Do we have any asymptotes? No. Why not?
There aren't any fractions.
Right, okay, good. So if it's a rational function, you'll want to, check for horizontal and vertical asymptotes. Okay, so now let's do local extrema. Which derivative do we use for that?
The first.
The first. So I'm going to take that. Right, set it equal to 0. Don't divide things away. Okay, you don't want to lose that x squared or you'll lose one of your points. So what can we do? Factor out of 4x squared. And if you're good doing that in your head, that's fine. And then we can just put our -6 and our 0 on the number line. Okay.
That's the
Out of the
problem.
way. Okay, so -7, remember I like to put it in the factored form of the derivative. I think that's easier. So anything that goes into 4x squared is going to be positive, right? So all I really have to worry about is this one quantity right here. So when I put in a -7, it's going to be negative. When I put in a -5 or -1, whatever you pick in here, it's going to be positive. Ditto over here. So that means that my function is decreasing, increasing, increasing. Because that was your first derivative. So f prime, Preston, f prime is negative, positive, positive. So my function was decreasing, increasing, increasing.
So it's
You just keep going up.
it's
Yeah.
gonna be like a cubic.
Yeah, kind of like maybe part of that function we were looking at yesterday where Veronica's, the x plus cosine x, where we're like, is it going to do that? Yeah. Okay. Now let's look at concavity using what?
The second derivative.
Yep. So let's take the second derivative. And set it equal to 0. Again, do your factoring stuff.
Oh, did you try?
I know. I hope that wasn't bad. These things were
The
going
pen.
so well.
Yeah.
Okay, so you have your numbers on your number line. We'll test the -5. Now here we do have to worry about both of these, right?
This -5 would make
Oh, that's
Are we good? Okay, yeah, negative and negative, good. It would make a positive.
it's like, that's a 4.
How about a -3?
negative.
Negative, positive, right? Negative,
And positive.
and then good.
So
Okay. So
down. Up.
right, up, down, up. Okay, so now I can scroll a little bit, and then let's identify those points as whatever they are, right? Here I have something, because I'm switching from decreasing to increasing. So -6 something is a what?
Min.
Good. How do I figure out what the y value is? Yepper. Okay, good. So g of -6 is 2. That's true. All right, so that's your minimum. And what do we have going on over here? What are those? They are something.
Absolutely. They're points of inflection.
Ding, 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 ding.
All of y'all are wrong.
All right, so you go back to the same place to get your y values. 6 on. And I like the 0. Yeah, 0's nice. All right, so I think I left us kind of a lot more room than we needed because we have everything we need now. Okay, all we have to do is put it all together.
That was for last year.
Go like this instead of using the lines because I want to hurry up. All right, so we had 3 points to graph. Plus, you do have your your y-intercept. We're going to end up graphing anyway. The 0, 200. It's also a point of inflection. Make sure you label all of the important points. All your extrema and your points of inflection, you want to label them on your graph. -232. What was that? -4, -232, right?
-6.
Oh, okay. And obviously your x scale and your y scale do not have to match each other, or you wouldn't really be able to see anything. Okay, so -6, we'll just say it's there. -4, -56, was that a point?
Yeah.
Okay. So we have our 2 points of inflection and our minimum, right? How I graph these is I look at my second derivative number line. You guys can look at yours. Mine is up off the page. But you know that from -4 back, it was concave up, right? So from -4 back, it's concave up. And I want to hit my min along the way. So
Is
from
it gonna be like a W that's like
yeah, yes. Yeah. My stuff on it. Okay, it's going to be that. That's my concave up. And then, right, now between -4 and 0, it's concave down. Yeah, I see a lot of you guys drawing it in the air. So now we have from here to here, it's our concave down. Mine's almost looking a little too linear for my liking, but
It's because our y values are
yeah, they're right.
all the way here, but
This
our
is
x
a heck of
values
an x cubed stretch day. It's
are-
like
it's
a,
like
yeah.
the x values are so close.
And then your concave up. So concave down, concave up. Try to make yours look a little better than mine.